Hello everyone, today we are going to look at the SPM partial clone questions which involves indices and logarithms. So we're going to do a total of 10 questions. So now here, question number 1, given that a to the power of k in the brackets and to the power of h is equals to the cube root of a times the cube root of a, which is 4 times, where k and h are constants. State the value of k and h. So the first thing we notice here is this term. All 5 of these, they are the same terms. We can simplify this part, we can simplify it to the cube root of a to the power of 5. Since there are 5 of them, 1, 2, 3, 4, 5. And this is equals to a to the power of k to the power of h given. So from here we can see that if we can write the cube root here in the indices form, then this will be exactly the same as the right hand side will be exactly the same as the left hand side. So here we have this equals to, so cube root, if you want to write in the indices form, it will be a to the power of 1 over 3. So now we have this. So by comparison, k equals to 1 over 3. So you write there by comparison, k equals to 1 over 3 and h equals to, this h equals to 5. Question number 2. Given log base a of b equals to x, expressed in terms of x, this. So what we need to do here is try to convert this so that this will be in the form where it contains this term. And we can replace this term with x. Okay, so here we can see that 1 over b to the power of 2, we can write this as log base a of b to the power of negative 2. Okay, so you're using the law of indices here. So the 1 over b to the power of 2 is actually b to the power of negative 2. Then we can use the power law, and then we write negative 2 here. It becomes negative 2 log base a of b. And since this is x, I just replace this with negative 2x. Next, notice that the base is different. Okay, so when the base is different, the first thing we do is always change the base by using the formula log base a of b equals to log base c, and the b right here over log base c of a. And now we try to convert this to log of base a. Okay, so this part here, I just rewrite it as a to the power of 3 over b. Log base a of this one, square root of a. Then for this part here, the numerator part, we can use the division or the quotient law. We can rewrite this as a to the power of 3 minus log base a of b over log base a of a. Okay, so this is the square root. We can write this in the indices form, which is 1 over 2. So the next thing is we use the power law. We can write the 3 here as the coefficient for log base a of a. So now it becomes 3 log base a of a minus log base a of b over this. We also use a power law. We write this as a coefficient of log base a of a. You get this. I write the solution at the other side here. 3 log base a of a is actually equals to 1. Okay, so you have this times 1. So for those who don't remember this, log base a of a always equals to 1. So it means that log base, any number here, let's say 3 of 3 is equals to 1. Hence, here the log base a of a is 1. Minus log base a of b is given as x. So I just write the x here. And here log base a of a is 1, hence I have 1 over 2 left. So I just simplify this part. I get 3 divided by 1 over 2 minus x divided by 1 over 2. 3 divided by 1 over 2 is 6, where x divided by 1 over 2 is 2x. Hence this is the final answer. Question 3a, given log base a of b equals to p, state the conditions of a and b. So first we look at the base for a logarithm. The base for a logarithm must be positive and cannot be 0. Hence, a must be greater than 0. But there is one additional condition, which is a cannot be 1. Okay? A is a positive value greater than 0 and it cannot be 1. Next, for b must be a positive value and it cannot be 0 as well. Hence, b is greater than 0. Next, for b, log base 5 of y equals to 4 over log base xy of 5. Express y in terms of x. So if you want to express y in terms of x, our final answer y must be equals to an algebraic expression which involves x. So the first thing we will notice here is the base is different. So if you want to get rid of the log, the first thing you need to convert the expression here so that they have the same base. Hence, I'm converting the y to 5 by using the laws of changing the base. So I rewrite my equation here. I get this. We ignore the 4 for now. And here we change this part, the denominator part becomes log base 5 of 5 over log base 5 of xy. So we try to simplify this right hand side. You have this, you get 4, and you have this log base 5 of xy over log base 5 of 5. Since log base 5 of 5 is 1, we can write this as log base 5 of y equals to 4 log base 5 of xy. Then we continue here. Before we can compare the right hand side and the left hand side and the right hand side, we need to use the power law to bring the 4 to here. So you rewrite this as this equals to log base 5 to xy power of 4. Notice that the power of 4 applies to both x and y, not just y. This is one of the common mistakes. Hence, since both log has the same base, by comparison, so you write here by comparison, y equals to xy to the power of 4. But remember, we need to write y in terms of x, so we still have to simplify this. This becomes y equals to x to the power of 4 over the power of 4. Okay, so if I bring the x to the left hand side and the y to the right hand side, I get 1 over x to the power of 4 equals to this. I rewrite this, I get y to the power of 3 equals to 1 over x to the power of 4. Hence, this equals to, and finally, the power of 3, if you move this to the right, it becomes power of 1 over 3. Multiplying negative 4, I get negative 4 over 3. This is the final answer. Question number 4. Solve the equation. Again, notice that the base is different. Hence, we better change the base. So we are going to change the base for of square root of k. I rewrite this here, I get this. So the changing of the base here becomes log base k. Okay, log base k of here. This one I have 4k. Here with the square root of k is this equals to 2. So now we're going to simplify this by writing this, the square root, as the indices, which is 1 over 2. And by using power law, we can bring 1 over 2 here. Hence, it becomes this 1 over 2 multiplying log base k of k. And remember, because log base k of k is 1, hence we can rewrite this as log base k of 4k over 1 over 2, since this is 1. And when you divide by 1 over 2 here, you can simplify this and it becomes 2. Then we use the power law, we can bring the 2 here, it becomes log base k of 256 minus log base k of 4k to the power of 2. Now, since we have the same base here, these two terms, we can use the quotient law and combine these numbers. So now I have this 256 Because of minus here, the quotient law, it becomes divide 4k squared, which is 2. Now to get rid of the log, we can rewrite this equation by taking k here as the base number to the power of 2. So what I mean is you can move the k here, it becomes 256 over, so here 4 squared is actually 16 k squared, and the k to the power of 2. Now I move the k squared here, I get 256 over 16 k to the power of 4. 256 divided by 16 is actually 16, and 16 is actually 2 to the power of 4. Hence, by comparison, k equals to 2. One thing to note here is 16 can also be negative 2 to the power of 4. So why don't we use this? Because if we use this, k will be equal to negative 2. But according to here, since k is the base of the log, it must be a positive number. Hence, k must have a positive value. Okay, we proceed to the next question. Question number 5. Given 3 to the power of k plus 2 times 3 to the power of k equals to 3 to the power of h. Express k in terms of h. So the first thing we do here is always we try to factorize this, try to group this together, and then we try to do comparison of the left hand side and right hand side to get the equation of k in terms of h. So first we look at the left hand side here, we try to factorize 3 to the power of k, and we get 1 from here plus 2 from here, okay, to equal to 3 to the power of h. So from here you get 3 to the power of k plus times 3 equals to 3 to the power of h. Or instead of this, actually you can see this as 3 to the power of k plus 2 3 to the power of k, which is actually equals to 3 to the power of k, which is exactly the same as this. So if you don't understand why you get this, you imagine you see a plus 2a equals to 3a. So the a is 3 to the power of k. Okay, so there's 1 3 to the power of k, you add 2 more 3 to the power of k, you get a total of 3 to the power of k. We come back to here. So 3 to the power of k times 3 is actually 3 to the power of k plus 1 using the law of indices. And now we have this. By comparison of the indices, since the base is the same, okay, k plus 1 equals to h. So k equals to h minus 1. Okay, now given this equals to 1, express p in terms of q. So we try to simplify this equation here by bringing this to the right. So it becomes 256 to the power of q plus 3 equals to 64 to the power of p minus 1 times 1, which is still 64 to the power of p minus 1. So we try to convert the base here so that it has the same base. So notice that 256 is actually 2 to the power of 8. Okay, 3 plus 3. And 64 is actually 2 to the power of 6. Hence now we already have the same base here. We can use comparison to compare the indices, but let's simplify the indices first. You get 2. 8 times q, you get 8q. 8 times 3, you get 24. Here, 6 times p, you get 6p. 6 times negative 1, you get negative 6. So since the base is the same, we can compare the indices. Hence, 8q plus 24 equals to 6p minus 6. And we want p in terms of q. Equals to 8 over q plus 30 over 6, and we just simplify this to get the answer. You get divide by 2, I get 4, divide 2, I get 15, divide 2, I get 3. Hence 4q plus 15 over 3. Question 7, given a to the power of 3 to the power of a equals to 7 to the power of b equals to 21 to the power of c. Express c in terms of a and b. Okay, I think there are several methods to solve this. Let's try to let this equals to a constant. Hence we have, if we log both sides of the values, we have this. So using a power law, we can rewrite this as this. Since 3 to the power of a equals to k, this equals to k, hence this and this also equals to k. Okay, so I can also rewrite this as 7 to the power of b equals to k. Hence, by using the same thing, I got b log base 10 of 7 equals to log base 10 of k. 21 to the power of c equals to k. So c log base 21 equals to log base 10 of k. So you can see that log base 10 of 21, if we move it here, okay, so I do it here, continue from here, c equals to log base 10 of k over log base 10 of 21. And 21 is actually equals to 3 times 7. Means I can use the product law. I can rewrite this as log base 10 of 3 plus log base 10 of 7. And notice that here we also have log base 10 of 3. We can rewrite this as log base 10 of 3 equals to log base 10 of k over a. Hence, this becomes log base 10 of k over a. And here, log base 10 of 7 actually is log base 10 of k over b. So this becomes log base 10 of k over b. Okay, so c equals to this. So now we are able to relate c, a, and b in one equation. So if I continue from here, so I can actually factorize log base 10 of k from these two terms fraction here. So I get 1 over a plus 1 over b. This we can cancel off. I get c equals to 1 over a plus 1 over b. Hence we just simplified this. We get this equals to, this is a plus b over ab, which is ab over a plus b, which is the answer. Question 8. Given log base a of 3 equals to k, expressed in terms of k, log base a of 729 over a. So question number 1 here, it's very obvious that we can use the product law, and we can rewrite this as log base a of 729 plus log base a of a because of the product law. Okay, log base a of a is 1, hence we just have to do something with 729. 729 is actually 3 to the power of 6, and using the power law we can rewrite this as, and since log base a of 3 equals to k, it becomes 6k plus 1. Question number 2, log base 3 of 81 square root of a, and then, okay, so first thing we notice here is the base is 3, here the base is a. So when the base is different, the first thing we can do is we try to change the base to a. So we can write this as this, log base a. Okay, so 81 square root of a, and 3 will be here. Now we have this as k, and we just have to simplify here by using, we can start by using the product law. I can rewrite this as log base 81 plus log base a of square root of a. And since the denominator is k, it becomes this k. Then we have 81, which is 3 to the power of 4. Get 3 to the power of 4 over k plus, here square root is power of 1 over 2, and we just simplify this. Okay, we use the power law, we bring the 4 here, you get 4 over k log base a of 3 plus, here use the power law, you get 1 over 2 divided by k, which becomes 1 over 2k log base a of a. We simplified this because log base a of 3 is k, k and k cancel off, I get 4, and here log base a of a is 1, so I get 4 plus 1 over 2k. That is the final answer. 9. Given 3 to the power of x equals to p, 3 to the power of y equals to q, and this express p in terms of q. it's very obvious that we need to change this. So we have to convert this part and this part. Okay, I try to rewrite this question again. Plus 11 equals to 9 to the power of x. So for these terms, we can rewrite this as 3 to the power of y multiplying 3 to the power of 2x by using the law of indices. And the 9 here is quite obvious that it is 3 to the power of 2, and with the x here it becomes this 2x. Now you need to know that 3 to the power of 2x can actually be written as 3 to the power of x2. So it can be written as 3 to the power of x to the power of 2 here. Okay, so since 3 to the power of x is p, hence this part here it becomes p to the power of 2. 3 to the power of y is given as q plus 11, and here is the same we have, which is p to the power of 2. Okay, because this part here is p, so the 2 here will be p to the power of 2. Now we just need to simplify this, but since we want to express p in terms of q, so I bring the p to the left hand side, I get this. Then I just factorize the p here, I get q minus 1. The 11 I move here, I get negative 11. And then we get p squared equals to negative 11 over q minus 1. And p equals to the square root of negative 11 over q minus 1. So even though there's a negative here, but it can also be a negative value here, and you get the square root of a positive value. But we're not done here. One thing to note is, since p equals to 3 to the power of x, so no matter what's the value of x, since the base 3 is a positive value, p must be positive. Hence the final answer is p equals to the square root of this, which is a positive value. For our last question, question number 10, given log base p of 2 equals to k, log base p of 5 equals to h, express this in terms of k and h. Hence I rewrite this. Okay, so this log base 5 of 16 p to the power of 3. You can see that the base is different. Here we have 5, but given here is p. Hence the first thing we do, we change the base. It becomes log base p, okay, of 16 p to the power of 3 and 5. I rewrite the 5 here. So for the numerator part, we can rewrite this using the product law. I get this plus log base p to the power of 3 over log base p of 5 is actually h, so I just use the h here. So since we are given this, okay, so we can convert 16 to an indices with base 2, which is 2 to the power of 4. Hence we convert it to this. And by using the power law, we can bring the 4 to the front as a coefficient. Hence I just skip a step and write the 4 here. Here is the same as well. I can put a 3 here. I get 3. And log base p of p is actually equals to 1. Okay, I get this. Okay, and now the final part, log base p of 2 equals to k. Hence I get 4k plus 3 over h. That will be the final answer. So this is the end of this video. Please refer to the description for any corrections. Thank you everyone. I'll see you in the next video.